All right, welcome back everyone to the deep dive. We've got some really cool stuff to unpack today.
Yeah, this is going to be a fun one.
You guys sent in some pretty dense material, but we think there's some real gems in here. So
Definitely some valuable insights to extract.
yeah, and today we're going to be laser focused on Annex A of ISO slash IEC 22989:2022.
Yes, Annex A. A bridge between worlds, you might say.
Okay, now we know that just hearing the phrase standards document can make some eyes glaze over.
I can relate. Been there.
But trust us on this one, this particular section, it's kind of like a Rosetta Stone for understanding how different organizations, different bodies are thinking about the entire life cycle of AI systems from start to finish.
Exactly, and what's really neat about Annex A is it connects the very specific granular stages of the AI system lifecycle, as laid out in Clause 6 of this ISO standard, and it maps them onto the higher level definition that the OECD uses.
And just for everyone listening, OECD, that's the Organization for Economic Cooperation and Development.
Right, a big player on the global stage, particularly when it comes to setting guidelines for AI.
Exactly. So what we're going to do today was really walk you through this mapping. Think of us as your instructors, your guides, helping you connect the dots between these two important frameworks. We'll go step by step, unpacking what each connection means in a practical sense for anyone who's involved in AI development or even just trying to wrap their heads around how these systems evolve over time.
Think of us as your Sherpas through this potentially challenging terrain.
Yeah, exactly. And the reason this mapping is so important is that it creates this crucial alignment, this kind of shared understanding across the entire AI landscape. So whether you're the person actually coding the algorithms or you're the one setting the policies or somewhere in between, everyone can be on the same page about those fundamental phases that an AI system goes through.
Yeah.
And that's huge for making sure we're all working towards responsible, trustworthy AI.
Couldn't agree more. It's all about establishing that common ground.
Absolutely. So why don't we dive right in? Let's start by getting a clear picture of what the OECD, what their view of the AI system life cycle is. I mean, what are those core stages that they lay out?
Right. So Annex A tells us upfront that its purpose is to map Clause 6 of ISO/IEC 22989 to the OECD's definition, which comes directly from a document they put out called Recommendation of the Council on Artificial Intelligence. You can find it online if you're interested in reading the whole thing.
Sounds pretty official. So what does it say? Like, what are the big phases that the OECD identifies for an AI system's life, so to speak?
So they break it down into four key stages. The first one is design, data, and models.
Okay, design, data, and models. That makes sense. It's got to start somewhere.
Yeah, and they describe this stage as a sequence that can vary depending on the context. But in general, it covers all the initial steps from planning and designing the system to gathering and processing the data it'll use to actually building the AI models themselves.
Okay, so it's kind of like laying the foundation and constructing the basic building blocks. What comes next?
The second stage is verification and validation, making sure it's all working as intended. Then you have deployment, which is, getting the system out into the real world and up and running. And finally, there's operation and monitoring, which is about overseeing the system once it's live, making sure it's performing well, and catching any issues that might pop up.
So it's kind of like a birth to retirement flow for an AI system. But I seem to recall seeing somewhere that the OECD emphasizes that these stages, they don't always happen in a strict linear sequence, right?
You're absolutely right. That's a really important point they make. The OECD is very clear that these stages can, and often do, overlap. And they can even loop back on each other. It's not like you check one off and move neatly to the next.
So it's more like this iterative, this kind of back and forth process.
Exactly, yeah. You might find, for instance, that during the operation and monitoring stage, you discover something that forces you to revisit the design phase and make adjustments.
Okay, so it's dynamic. It's not a one-way street.
And another interesting point the OECD makes is that the decision to retire an AI system, to take it offline, to basically end its life, that can happen at any point during the operation and monitoring phase. So again, it underscores that an AI system's lifespan is not necessarily this neat, predictable timeline.
It's all about adapting to circumstances, reassessing, and making sure the system is still serving its purpose. Or if it's time to sunset it. Okay, so we've got this really clear picture now of how the OECD views the AI lifecycle. It's this dynamic four-stage process, but it's not rigid. There's room for flexibility and adaptation. So now let's bring in ISO/IEC 22989 and see how its Clause 6 aligns with this view. Let's start with that first stage, design, data, and models.
Yeah.
How does the ISO standard kind of map onto that initial phase?
So the OECD's design, data, and model stage, it actually covers two stages that are described in Clause 6 of ISO/IEC 22989. Those are inception and design and development. Let's start with inception. That's covered in Section 6.2.2 of the standard.
All right, inception, the very beginning.
Okay.
What are the key activities that happen at this point that feed into that design data and models focus that the OECD has?
Right. So inception is really about setting the stage. It's all about, first and foremost, defining the objectives of the AI system. What is it supposed to do? What problem is it aiming to solve? What need does it address? It's about, having that clear purpose in mind.
So it's not just about, hey, we have this cool AI idea. It's about, what is this AI actually going to do in the world?
Exactly. And the standard is very specific about the need to gather requirements for the system. What are those must-haves, those nice-to-haves, those constraints? And this is where it gets really interesting, because ISO/IEC 22989 emphasizes that at this early stage, you need input from multiple stakeholders.
So it's not just the developers in a silo coming up with this stuff.
Right. You have to consider the perspectives of the people who will be impacted by the AI system, the people who will be using it, the people who might be affected by its decisions, bringing those diverse voices to the table right from the start.
That makes sense. It's about anticipating those potential impacts.
Yeah.
And making sure you're building something that's going to be beneficial for everyone involved.
Absolutely. And there's also this acknowledgement in the standard that some AI systems, particularly those using machine learning, have inherent limitations in their predictability. So, you can't always know exactly how the system will behave in every situation.
Right, which makes it even more important to have those diverse perspectives and really think through those potential unknowns.
Absolutely. And inception also involves taking into account any relevant legal or regulatory frameworks. What are the rules of the road for this type of AI system?
Okay, so it's really about laying that solid foundation, thinking through the purpose, the limitations, the ethical considerations, and the legal landscape. That's a lot to pack into the very first phase.
It is, but it's all essential groundwork for making sure that the AI system you're building is going to be aligned with responsible AI principles from the very beginning. And it doesn't stop there. Inception also includes the initial steps in risk management.
Okay, risk management. That sounds important, especially with AI.
It's crucial. So at this early stage, you're identifying potential risks associated with the system. You're assessing their likelihood, their potential impact, and you're starting to think about how those risks might be mitigated or addressed.
So it's kind of like a preemptive strike, right? You're trying to anticipate those potential problems before they even arise.
Exactly. And alongside risk management, you're also weighing the potential benefits that the AI system might offer alongside any potential harms it could cause. So it's not just about preventing bad outcomes, it's also about making sure the system is actually doing good in the world.
Right. It's about striking that balance between the potential upsides and downsides.
And this ties into another key aspect of inception, which is considering the ethical values that will guide the system's development. So what principles will inform the design choices? How will you ensure fairness? How will you address potential biases? Those kinds of things.
So it's about baking those ethical considerations into the DNA of the system right from the start.
And then there are the more practical considerations like the financial aspects. How much will it cost to develop and deploy the system? Where will the funding come from? Is it actually financially viable? And importantly, you have to think about resource planning. What kind of data will you need, especially for machine learning systems? Do you have access to that data? Is it ethically sourced? Those kinds of things.
Okay, so there's this whole web of considerations, everything from the high-level ethical principles to the nitty-gritty logistics.
Right. And finally, the inception phase includes a feasibility assessment. So you're essentially asking, is this actually doable? Can we actually build what we're envisioning? And does it make sense to move forward? This might involve creating a proof of concept, a kind of prototype to test the core ideas and see if the proposed system is technically and practically viable.
Wow, so it's a really comprehensive process just to get to the starting line, so to speak. It's really impressive how ISO/IEC 22989 and the OECD are both emphasizing risk management so early in the AI life cycle really highlights that proactive rather than reactive approach to potential issues.
Absolutely. And notice how many of these inception activities, they're feeding directly into those core elements that the OECD highlights in their design, data, and model stage. So you can see that alignment already starting to take shape.
Yeah, it's like those initial steps are laying the groundwork for the actual design and building of the AI system. Okay, so we've covered inception in detail. Now let's move on to the next stage in Clause 6, which is design and development, outlined in Section 6.2.3. How does this stage then build upon those inception activities and contribute to the OECD's vision of design, data, and models?
So in the design and development stage, you're moving from those high-level plans and ideas that were formulated during inception, and you're starting to make those concepts concrete. This is where the design really starts to take shape.
Okay, so it's like moving from blueprints to actually building the structure.
Exactly. So in design and development, you're making key decisions about the architecture of the system. What kind of hardware will it need? What software components will be used? Are you building everything from scratch? Are you integrating existing tools or platforms? Those kinds of foundational choices.
Right, those big picture decisions that will shape how the system actually functions in the real world.
And of course, this is also the stage where the actual creation of the AI system begins. So you're writing the code, you're preparing the data, you're training the models, all those core development tasks.
So it's really the hands-on construction phase where those abstract ideas from inception start to turn into tangible algorithms and models.
Exactly. And this is all happening within the context of those requirements and objectives that were defined during inception. So you're not just building blindly, you're building with that clear purpose and those constraints in mind.
So it's like building a house. You have the architect's plans, but then you need the builders to actually bring those plans to life.
I like that analogy. And this whole design and development stage is really what fleshes out those design, data, and models that the OECD talks about. It's where those elements come together and start to take form.
That makes sense. It's kind of like that first OECD stage is this broad concept, and then ISO/IEC 22989 breaks it down into these two distinct phases, inception and design and development, which gives us a more nuanced understanding of what's actually happening in that initial part of the life cycle. Okay, so we've covered how those first two ISO stages map onto the OECD's design, data, and models phase. Let's move on to the second OECD stage, which is verification and validation. How does ISO/IEC 22989 tackle this crucial aspect of the AI lifecycle?
Well, this one's actually pretty straightforward. The OECD's verification and validation stage aligns almost perfectly with the verification and validation stage that's detailed in Clause 6 of ISO/IEC 22989, specifically Section 6.2.4.
Okay, so it's a pretty direct one-to-one mapping there. But just to be sure we're all on the same page, can you break down what kinds of activities typically happen in Clause 6's verification and validation?
Sure, verification and validation is all about making sure that the AI system you've built actually does what it's supposed to do and meets those requirements that were laid out earlier. It involves a bunch of different testing activities.
Okay, so lots of testing. Makes sense. You want to be sure it works.
Yeah, you got to put it through its paces. So first off, you've got software testing. That's about identifying and fixing any bugs or glitches in the code. Then you've got hardware testing, making sure all the physical components are functioning properly. And then there's systems integration testing, which is about ensuring that all the different parts of the system, the software, the hardware, the AI models, that they all work together seamlessly. You don't want any hiccups when they're all connected.
Right, it's like making sure all the gears mesh together smoothly. What else?
Then there's performance testing. This is where you're evaluating things like the system's speed, how quickly it responds, how much computing power it uses, how efficiently it performs overall, and you're comparing those metrics to predefined benchmarks.
So it's not just about whether it works, it's about whether it works well and efficiently.
Exactly. And this is crucial for AI systems, there's a specific focus on verifying that the AI models, the algorithms at the heart of the system, they're performing as expected. And this often requires using carefully curated test data sets. So data that's specifically designed to challenge the AI and see how it handles different scenarios.
Right, like putting it through a series of exams to make sure it's learned its lessons.
Exactly. And finally, there's typically an acceptance process. This is where all the stakeholders, the developers, the users, the people who will be affected by the system, they all review the results of all these tests and basically sign off saying, yes, this system is ready to move to the next stage.
Okay, so it's like a final checkpoint where everyone involved gets to weigh in and make sure they're comfortable with how the system is performing. And is this all happening in isolation, or is there any connection back to those risk management activities we talked about earlier?
Yeah. Oh, absolutely. Throughout this entire verification and validation phase, all the results of the testing are being fed back into those ongoing risk monitoring and review processes. So if any unexpected issues pop up during testing, that might trigger a reassessment of the risks and potentially even a revisiting of some of those earlier decisions that were made during inception or design and development.
Okay, so it's a very iterative process. You're constantly learning, adapting, and refining your understanding of the system and the potential risks. It's interesting how verification is often described as building the thing right, meaning it meets the specifications, while validation is about building the right thing, meaning it fulfills the user needs and its intended purpose. It's like a two-pronged approach to ensuring quality and responsible development. Okay, so that's a really clear picture of how ISO/IEC 22989 tackles verification and validation and how it aligns with the OECD's focus on that stage. Now let's move on to the third OECD stage, which is deployment. How does Clause 6 handle that transition of an AI system from this controlled development environment out into the real world into practical use?
Well, similar to verification and validation, the OECD's deployment stage has a pretty direct counterpart in ISO/IEC 22989. It aligns very closely with the deployment stage that's described in Clause 6, specifically in Section 6.2.5.
Okay, another clear parallel.
Yeah.
But just to break it down for our listeners, what are the key things that are happening in Clause 6's deployment stage? What are the main considerations and activities?
Deployment is all about getting the AI system out of the development environment and into the real world, into that target environment where it's going to be actually used and hopefully provide value.
Okay, so it's like launch day, right? You're putting the rocket into orbit.
Exactly. But it's not as simple as just flipping a switch. There's a lot to consider. First and foremost, you have to think carefully about the characteristics of that target environment. An AI system might be developed in a very controlled setting, but then it might be used in a much more unpredictable, much more messy real-world environment.
Right. It's like the difference between testing a self-driving car on a closed track versus letting it loose on city streets.
Exactly. And the standard also points out that the software components of the system and the AI models themselves, they might be deployed separately. So you might have, the software running on one set of servers and the AI models running on another, or you might have a hybrid approach, different parts of the system deployed in different ways.
Okay, so there's some flexibility in how the actual deployment happens. What else is important to consider during this stage?
Well, you've got the actual installation of the system,
Hmm.
getting it set up in the target environment. Then there's the release process, making it available to users. And then there's all the configuration settings, making sure it's tailored to the specific environment and the specific needs of the users.
Right, like setting it up and customizing it.
And then, of course, you've got to think about things like repairs, updates, troubleshooting.
Hmm.
What happens if something goes wrong? How do you fix it? How do you keep the system running smoothly?
Right. It's like having that IT support team standing by.
Yeah. And then there's the user support and training aspect. How do you make sure that the people who are actually using the system understand how to use it effectively, how to get the most out of it, how to avoid any potential pitfalls?
Okay, so it's about supporting the users, not just deploying the technology. And what about risk management? Does that come into play at all during this deployment stage?
Absolutely. Risk management is an ongoing process throughout the entire AI lifecycle, and that definitely includes deployment. So as you're rolling out the system, you're still monitoring for potential risks, you're still assessing the impact of those risks, and you're still taking steps to mitigate those risks.
Okay, so it's not just about getting the system out there and then hoping for the best. It's about carefully managing those risks every step of the way. It's great how the standard emphasizes that deployment isn't just a technical handover, but actually a whole phase that requires ongoing monitoring and support. It really reflects those real-world complexities of actually integrating AI into different environments. All right, so now we arrive at that final OECD stage, operation and monitoring. How does Clause 6 map onto that ongoing use and oversight of an AI system, particularly given the OECD's mention of potential retirement within this phase?
Okay, so the OECD's operation and monitoring stage, it primarily lines up with the operation and monitoring stage in Clause 6 of ISO/IEC 22989. That's detailed in Section 6.2.6. This is the stage where the AI system is live, it's running, it's doing its thing out in the world.
Right, so it's showtime, the curtain's up, the AI is performing.
Exactly. And the activities here include all those day-to-day things that keep the system running smoothly. You've got the actual operation of the system, making sure it's up and running, monitoring its performance, collecting data on how it's being used.
Right, keeping an eye on things, making sure
Yeah.
it's doing what it's supposed to be doing.
Yeah, and you're also gathering feedback from users. Are they happy with the system? Are they encountering any problems? Are there any improvements that could be made? And then there's incident management, dealing with any failures or unexpected events that might occur. And of course, there's ongoing maintenance, doing repairs, providing updates, making sure the system stays secure, all that good stuff.
Okay, so it's about keeping the system healthy, making sure it's performing well, and responding to any issues that might pop up. And and throughout all of this, are we still keeping an eye on those risks?
Absolutely. Risk management is a continuous process, so even during the operation and monitoring phase, you're still monitoring those potential risks, you're still assessing their impact, and you're still taking steps to mitigate them.
Okay, so it's like being a doctor. You don't just treat the patient and send them home. You have to follow up, you have to monitor their progress, you have to make adjustments as needed.
Perfect analogy. And this ties into the OECD's point about potential retirement.
Hmm.
Even while a system is operational, you might realize that it's time to retire it, to take it offline, to end its life.
Right. So it's not just about keeping it running forever. It's about recognizing when it's reached the end of its useful life or when it's no longer serving its purpose. So how does Clause 6 specifically address that potential for retirement during the operation and monitoring phase?
That's where sections 6.2.7, 6.2.8, and 6.2.9 of Clause 6 come into play. They cover continuous validation, reevaluation, and retirement. These stages really flesh out that concept of ongoing assessment and potential retirement that the OECD highlights.
Okay, so those are kind of like the sub-stages within operation and monitoring that deal with that longer-term perspective.
Exactly. So continuous validation, that's particularly relevant for AI systems that are using machine learning and that are constantly learning and evolving. The idea is that you're not just validating the system once at the beginning, you're continuously validating it as it learns and changes.
So it's like giving the AI system regular checkups to make sure it's still healthy and performing well.
Right. And this also includes constantly improving those risk management processes, taking into account the data that's being collected while the system is live. Then you have reevaluation. This is a more formal reassessment of the entire system, and it might be triggered by changes in the environment, by new requirements, by the results of the ongoing monitoring, or maybe even by feedback from users.
So it's like taking a step back and saying, okay, how are things actually going? Is the system still meeting our needs? Do we need to make any adjustments? Is it still aligned with our values?
And this reevaluation might lead to refining the original objectives, adjusting the requirements, and of course, continuing that risk monitoring and mitigation. And then finally, you have retirement, which is the process of formally decommissioning the system, taking it offline, and either discarding it or replacing it with something newer, something better, something that better meets the current needs.
Okay, so it's about recognizing that an AI system doesn't necessarily have an infinite lifespan.
Uh,
There might come a point where it's time to say goodbye.
And those three stages, continuous validation, reevaluation, and retirement, they really capture that aspect of the OECD's operation and monitoring stage that deals with that long-term view, the potential for ending the system's life, even while it's still operational.
It's a very holistic perspective on the life cycle of an AI system. It's not just about building it and deploying it. It's about managing it responsibly throughout its entire lifespan and recognizing when it's time to let it go.
That's really insightful. Now, I know our outline also mentioned that Annex A includes some overarching points from the OECD that apply across all these stages. So beyond the specific stages themselves, what are some of those key principles that they emphasize?
Right. So Annex A brings in some really crucial principles from the OECD, especially when it comes to robustness, security, and safety. And these are things that need to be considered throughout the entire AI lifecycle, not just during specific stages.
Okay. Robustness, security, and safety. Those those sound like pretty fundamental principles, especially when you're talking about AI systems that are going to be operating in the real world. Absolutely. So the OECD really emphasizes that AI systems should be robust, secure, and safe throughout their entire lives. What does that mean? Well, robustness means that the system can handle unexpected inputs, unexpected situations, can adapt to changes in the environment. It doesn't just break down when it encounters something it hasn't seen before.
So it's like building a bridge that can withstand an earthquake,
Yeah.
right? You want it to be able to handle those unexpected stresses.
Exactly. And security means that the system is protected from unauthorized access, from malicious attacks, from data breaches, all those things that could compromise the system's integrity and potentially harm people.
Okay, so it's about keeping the bad guys out and keeping the data safe. What about safety?
Safety means that the system won't cause harm to people or to the environment. So it's about making sure that the AI system's actions, its decisions, its outputs, that they're not going to put people at risk.
Right, so it's not just about protecting the system itself, it's about protecting the people and the world around it.
Exactly. And the OECD is very clear that these principles of robustness, security, and safety, they apply to every stage of the AI lifecycle. So it's not just something you think about during development, it's something you have to consider during deployment, during operation, and even during retirement.
Okay, so it's a constant thread that runs through the entire process. Now, how do you actually ensure these principles are upheld? Like, are there any specific mechanisms or tools that the OECD recommends?
Yeah, one of the key things the OECD emphasizes is traceability. They're basically saying that AI actors, the people who are building and deploying these systems, they need to maintain clear records of what's happening throughout the AI lifecycle.
Okay, so it's about documenting the process, keeping a log of what decisions were made, what data was used, how the system was tested, that kind of thing.
Exactly. So you need to keep track of the data sets that were used to train the AI models. You need to document the processes that were involved in developing and deploying the system. And you even need to record the decisions that the AI system itself made where appropriate.
Okay, so it's like having a paper trail for the entire life of the AI system. And why is that so important?
Well, this traceability is crucial for a number of reasons. First of all, it allows you to analyze the system's outcomes, to understand how it's performing, to identify any potential biases or problems. It also helps you to understand the system's behavior, why it made certain decisions, why it produced certain outputs. And it's also essential for responding to any inquiries or concerns that might arise. So if someone asks, why did the AI system do this? Or how do we know this system is fair? You have that documentation, you have that evidence to support your answers.
Right, it's about being able to explain the AI's decisions, to justify them, to show that they were made in a responsible and ethical way. And I guess that's also important for building trust, both in the system itself and of the people who built it.
Absolutely. And it's not just about traceability. The OECD also strongly recommends adopting this systematic and continuous risk management approach at every phase of the life cycle.
So it's like that risk management thread we were talking about earlier, but it's even more specific here.
Right. So it's not just about identifying risks. It's about having a structured process for assessing those risks, for determining their likelihood and their potential impact, and for figuring out how to mitigate those risks effectively.
Okay, so it's about having a plan, a framework, a methodology for dealing with those risks. And what kind of risks are we talking about here?
Well, the OECD specifically mentions risks related to privacy, digital security, safety, and bias. So, how do you protect people's data? How do you prevent unauthorized access to the system? How do you ensure that the system's actions won't harm people? And how do you make sure that the system isn't making biased or unfair decisions?
Right, those are all huge considerations, especially as AI systems become more powerful and more integrated into our lives.
And it's not just about the technical aspects of risk management. The OECD also emphasizes the importance of considering the roles and responsibilities of all the different actors involved in the AI ecosystem. So who's responsible for what, who's accountable for what, who has the authority to make certain decisions.
So it's about clarifying those lines of responsibility, making sure that everyone knows what their role is in ensuring that the AI system is developed and deployed responsibly.
Exactly. And it's also about considering the specific context in which the AI system is being used. So, what are the unique challenges and risks in that particular domain, in that particular application?
Okay, so it's not a one-size-fits-all approach. You have to tailor your risk management strategies to the specific circumstances.
And it all comes back to those core principles of robustness, security, and safety. Those principles should be guiding everything you do throughout the AI lifecycle, from the very first design choices to the eventual retirement of the system.
That makes sense. It's like those principles are the North Star that you're always navigating by. Now, I know that Annex A also includes a helpful visual representation of everything we've been talking about. Can you tell us a bit about that?
Absolutely. Annex A includes Figure A.1, which is basically a diagram that shows how the stages in Clause 6 of ISO/IEC 22989 map onto the OECD's definition of the AI system lifecycle. It's like a side-by-side comparison, so you can see those connections very clearly.
So it's like a cheat sheet for understanding how those two frameworks align.
Yeah, exactly. It's a really useful way to visualize those connections and to see how those different stages relate to each other.
And it's a great reminder that even though these documents might seem dense and technical, the ideas behind them are actually pretty straightforward. It's all about building AI systems that are responsible, that are trustworthy, and that are beneficial to humanity.
I completely agree. And having those clear frameworks, those clear guidelines, that's essential for making sure that everyone involved in AI development is on the same page and is working towards those shared goals.
Right.